I will go ahead and share my screen. All right. All right. So everyone should be seeing my title slide here. So thank you for that. And thank you for joining today. So what we're going to attempt to do is go through and discuss the pesticide registration process. So this is a massive process, and I am not going to do it justice in a 1 hour discussion. And to be honest, the process is so large, it is so complicated that I really don't even understand all the parts of it. But what I am going to do is give you a snapshot today about what this process looks like so that you can have confidence in the process. And if you are using a pesticide and someone is asking you about it and they're concerned about what is going on with this material, what happens when it's in the environment, well, hopefully after this presentation you can explain to them and help them see and understand that this is a very rigorous process and no pesticide ever comes to the market without being fully vetted. So what I usually tell people is this presentation is like trying to put 10 pounds of rocks in a 5-pound sack, but we're going to do the best we can over the next hour or so and see what we can come up with. Okay, so we're going to try to work through some of these questions today. So we're going to talk about FIFRA. We're going to talk about what a pesticide actually is, how it's defined. We're going to talk about registration and labeling and why any of this actually matters. So it's very important to start this process with FIFRA. So FIFRA is the Federal Insecticide, Fungicide, and Rodenticide Act. This is the federal statute that governs everything having to do with pesticide registration, distribution, sale, use, and enforcement. So it is a massive, massive act. It is a massive set of statutory authority, and there's a lot that goes into it. So within FIFRA, it requires that all pesticides have a label. It requires licensing and training, storage, disposal, records depending on the type, record keeping depending on the type of pesticide that is used, and inspection requirements and all of these things. So FIFRA is a massive law that is governed at the EPA and at the state level. So the EPA is the holder of FIFRA. They are the primary responsibility holder of this legislation, but a lot of the enforcement is adjudicated to the states. And we'll talk more about how the state comes into this a little bit later. So with FIFRA being in place and it being the overarching laws that keep us safe with pesticides, the next most important question is, well, what is a pesticide? Well, according to FIFRA, it is any substance or mixture of substances intended for preventing, destroying, repelling, or mitigating a pest. All right, so this seems very straightforward, very simple, but let's get into this and let's kind of draw distinctions on what is and is not considered a pesticide. So, quiz time. First question, is this a pesticide? Well, I think that's an easy one. Yes, I think we all understand it's a herbicide. It's a herbicide we're all familiar with, and yes, it is considered a pesticide. Now, some folks will say, well, pesticides kill insects and herbicides kill plants. Not really. A pesticide is any product, remember, that is intended for preventing, destroying, mitigating, repelling a pest. So ones that kill insects are insecticides. Those that kill plants are herbicides, but they're all collectively a pesticide. All right, so what about this? Copper sulfate. Is copper sulfate a pesticide? It's a natural product. All right, it's not like something synthetic like glyphosate that we just saw. Well, of course it is. So the fact that copper sulfate can be used to kill a pest such as algae, then it is a pesticide. And if it's used that way, it has to be registered and maintained and monitored under EPA and FIFRA. What about pond dye? Is pond dye a pesticide? Well, now it starts getting a bit more murky, and I'll say that it depends. If the manufacturer claims that their product can be used to control algae, then yes, it is a pesticide and it requires registration. If they are just saying, no, this is to change the color of the water and promote a different look, that is not a pesticide because it's not being used to mitigate, destroy, repel a pest. So it's about the claim. All right. So it starts getting a bit more confusing here. What about these two? What about a mouse trap? Is that a pesticide? It definitely destroys a pest. Well, if it is a trap, they are not considered pesticides because those are sort of devices, right? So a plow on the back of a tractor is not a pesticide, even though it controls weeds. All right. So these types of things are devices and they're not pesticides. Now, this other fly sex lure, all right, this is basically fly paper. Is it a pesticide? Well, it actually is. Since there is an attractant in there, it is designed to mitigate a pest, to draw a pest, a fly to that paper and stick to that paper. That would be a pesticide. As such, it has an EPA establishment number. So really getting down into what is a pesticide, it seems easy on the surface, but it can get complicated pretty quick. Now, why did I even go through any of that? Why does that matter? Well, according to FIFRA, it says that no person in any state may distribute or sell to any person any pesticide that is not registered pursuant to Part 3 of FIFRA. All right. Okay. So why does that matter? Well, in other words, you can't just go out and start using things for weed control and that be legal. Okay. If you are going to use a pesticide, and again, that is a mixture of a substance or a mixture of substances that are used to mitigate, repel, destroy a pest, it has to be registered. So I've had people come to me and say, we don't like the herbicides that are being used in our park. I wish they would just use Clorox and salt. Well, all of a sudden, you have just manufactured a pesticide that is not registered by EPA, therefore, you can't use it. So, any pesticide, for you to use it, it has to be registered and it has to go through a massive registration process. So, just because Clorox and salt may be more familiar to a homeowner, that doesn't mean it's any safer. And it may even be worse because it has not gone through registration. So you can't just go decide to start using things. All right, so I've been talking about the registration process for the last couple of slides. So what is it and how does this work? Well, essentially registration is a series of scientific studies that all come together to collectively ensure that the pesticide will not generally cause unreasonable adverse effects on the environment. And guys, I would highly recommend that you write this statement down and do your best to commit it to memory because this is a very, very important statement. Will not generally cause unreasonable adverse effects on the environment. That is what the registration process attempts to do. All right, now it doesn't say no adverse effects, it says no unreasonable adverse effects. So, for example, let's say you're trying to manage disease carrying mosquitoes. Well, the disease in the mosquito, if it is more dangerous than the material or the control measure being employed, then it could be the fact that it is not unreasonable to use that pesticide to kill this disease carrying insect. So, we're not ever able to get to zero risk, but we're trying to get to no unreasonable adverse effect on the environment. Okay, very important distinction there. So, how does registration work? Well, you start with data and lots of it, and it takes a very long time to collect all of this. The registration process currently takes anywhere from 5 to 10 years to complete, and it's going to cost around $300 to $400 million because that is how much work has to be done to collect all the data that is required to go through the registration process. So, of that, there ends up being about 243 unique projects. I call them experiments here, but I think it's better to call them projects because some of these projects have multiple experiments within them. So there are 40 projects in the chemistry class, in toxicity, non-target organisms, et cetera, et cetera. So let's go through and talk about what each of these categories are, what questions they're trying to answer, and then we'll kind of close this up at the end and show how all of these things truly do interact to then form your label. All right, so we start with chemistry. There are 40 different experiments or projects involved here, and it's all about understanding what that active ingredient is. All right, so what is the concentration in the jug? What are the physical and chemical characteristics? Meaning, what is the vapor pressure? What is the flash point? Is it volatile? All of those things, just trying to understand the nature of the molecule itself. Okay, 40 different projects there. Secondly, they're going to look into toxicity. All right, and this is a huge series of projects. There are 55 unique projects, the vast majority of them with multiple experiments under each one. So this is where a lot of time and money is focused because it is so absurdly important. All right, it is so important to know. So this whole project is really about understanding the impact of this molecule to humans and domestic animals. Okay. Now they're going to look at acute toxicity. So how much of this molecule is required until you have a sudden and direct impact? That's your acute toxicity. But we're also going to look at chronic and subchronic. So really showing what low exposure for a long time does. But they're also looking at what happens to reproduction. What about the offspring and even the second generation after that? So they look to see if there's inherited issues that cause problems. They look to see if there's any mutations caused. So basically that's cancer. And they also look at disruption to metabolism. So in these projects, they do a tremendous amount of autopsy work and they screen these animals very, very closely to look at what impact that molecule is having on them. So after the toxicity work is done, they start looking at non-target organism effects. Again, this is a huge one, and you'll understand why in just a second, but there's 63 different projects, and there are general, short-term, and long-term studies, both in the lab and in the field here. So basically, there's a lot of time and effort, but think of it like this. We're very interested to know, A, does that pesticide kill the pest we're going after? Let's say it's a herbicide. Does it kill weeds? Yes or no? We understand that. Well, then secondly, well, let's say that this is an aquatic herbicide and it's being used to control cattails in a lake. Well, what happens if a duck comes and lands in those cattails after the treatment? So the duck was not the target. The target was the cattails, but what happens to the duck? What happens to the fish? What happens to the frogs? What happens to the insects, the spiders that are living in those cattails? All of these things, these are all non-targets. We're not trying to harm them. We're only trying to remove the cattails. But you have to look at how all of those are impacted. Huge study. And the reason this is so important is, again, to ensure that there will be no unreasonable adverse effects on the environment. Okay? Again, we're back to that. Remember that term. It will not generally cause unreasonable adverse effects. Okay, so these are some very big, long-term, extremely expensive experiments that we've just gone through with chemistry, toxicity, and non-targets. But now let's look at applicator and post-application, because this is very important because it deals very directly with those applying the pesticides as well as those coming in contact with them after the fact. Okay, so this is all about exposure. So understanding how this works and the level of exposure and how your body reacts to that through the toxicity experiments that have already been done. Now we need to know how much is getting on the applicator and what is happening to it after it does. So that then informs what protective equipment they need to use. It informs reentry intervals. So after a treatment has been applied, how long until someone can come in that area? I think we've all seen in our neighborhoods where a pest control company will come in, they'll treat the grass, and they'll put a sign in the yard that says, do not walk on the grass until it is dry. Or it'll say, do not walk on grass for 1 day, or something like that. That is all informed with this applicator and post applicator set of projects. Now, number three, I say use sites, and this is another very important one. So let's say there's a herbicide again that is it's sticking around on these plants. Let's say you applied it to a cornfield. Okay. Well, very few people walk through a cornfield after it's applied. So the amount of post-application involvement is very low because people don't traipse around in cornfields. However, what if you're talking about a soccer field? Okay, well, if it stays around on that grass too long, then maybe soccer fields will never be on the label because there is too much there and there's too much exposure after the application. So not only does this protect the applicator, but it protects those who come in afterward. All right, now drift. I think we're all aware of what drift is conceptually. It's basically your pesticide moving away from your target area into an area that you didn't intend to spray. Well, there's only 2 projects here, but these are 2 huge projects that only keep growing. Because now, if you remember previously, we said we have to understand what happens to non-target organisms that are in the site of application. That is the duck that comes in to the cattails, right? Now we have to understand if we drift and the pesticide leaves our target site, what's going to happen to any organisms that are outside of our treatment zone. So this is a big issue when you start talking about threatened or endangered species. So now we have to try to start figuring out what's going to happen outside of this, and are we likely to harm a threatened or endangered species if this pesticide drifts? This is extremely hard. There is a lot of modeling. There is a tremendous amount of buffer applied to these because if in doubt, you take uses off the label, you restrict how it can be applied, when it can be applied, and all sorts of things. So just because this is 2 projects, these are 2 massive projects trying to ensure that we're not harming something outside of the application zone. All right, we're kind of wrapping up here. So now we're at environmental fate. But because this is coming at the end of the list doesn't mean that it is not essentially and fundamentally important. Because environmental fate is asking the question, what happens after the pesticide is sprayed? Does it persist in soil? If so, does it leach into the groundwater? Does it run off into surface water? Does that pesticide, maybe it's very non-toxic as a pesticide, but does it break down in the environment into something that's toxic? They have to know that that's environmental fate. We have to know how is it degraded? How fast is it degraded? Because the longer something persists, the more careful we have to be, the less you can use and the less frequently it can be used. So understanding all of this degradation pathway is very, very important. And again, 16 huge projects conducted all over the country in water, in soil, and all sorts of different environments. Again, we can't contaminate because we cannot we have to make sure that we'll not generally cause unreasonable adverse effects to the environment. And where this really brought everything into attention was this molecule here. DDT, it was an insecticide that was very effectively used for human health. It killed mosquitoes, it killed all sorts of parasites, but DDT lasted forever and it did some really terrible things in the environment. And this molecule alone essentially led to the formation of the EPA. So it was a total revision. DDT led to a revision of FIFRA, the creation of EPA, the Clean Air Act, the Clean Water Act, all the things that came along with that. So we've got to make sure that these materials aren't persisting and doing harm like DDT did. We just simply cannot have a repeat of this. Okay, now we're on to residue. So 20 projects here, but these are critically important. So what we're looking at here is food accumulation. All right, so this is potable water. This is how much is in any potable water. This is how much is going to be on your food. And it's really about environmental load. And the question they're asking is, if this pesticide is used at the maximum rate on all of the use sites every year, how much will be in the environment and how much are you as an individual going to be exposed to that pesticide? So with that information, we're going to form tolerances. Now we're going to talk about tolerances in a minute, but this is another huge issue that we need to understand. So, and also with residue, that's where your accumulation studies come in. So how much is coming into your into your body? How much is leaving your body through either metabolism or excretion? And what does that balance look like? Because that's called bioaccumulation. And we need to know that exposure number so we can understand our complete exposure construct. Now, we've talked about collecting a lot of data. Well, who collects it? Well, it is the responsibility of the registrant to collect these data and provide them to EPA. Now, a lot of people will say this is a huge conflict of interest. So, is this a conflict of interest? We hear that a lot, so I'll just ask you, is it? Well, I would say possibly, but one of the things we have to keep in mind is how the data are collected. So who decides that? A company just simply can't go out and give EPA whatever data they want and say, hey, you sort it out. No, instead, EPA has guidelines for all of these 243 projects and the multiple experiments. And each experiment has a guide that is anywhere between 150 and 400 pages long that explicitly lays out exactly how the data must be collected. If you collect that data in a way that deviates from that plan in any manner, EPA will reject those data and tell them they have to be recollected and resubmitted. So yes, some people will say there's a conflict of interest since the registrant is collecting the data for their registration. But on the other hand, they're having to do that with strict alignment with how EPA requires the data to come in. Okay, so where are we? Well, we're standing on a mountain of data. 243 different projects, each of those with a massive number of experiments. So what now? Where do we go from here? Well, as I said a moment ago, we're now getting ready to talk about tolerances. So now that we've got all of this stuff, now we start getting into some really nitty gritty things. Now, guys, I'm going to need you to put your thinking caps on just for a minute here. The tolerance thing gets pretty complicated, and I hope I don't get tongue-tied trying to work through it, but it's a pretty complicated process. All right, so if you're going to set tolerances, first you start with your toxicity data and you develop dose response curves, okay? So let's say you take an experimental animal and you start feeding that animal, different animals, progressively higher amounts of the pesticide. So you've got this cohort of animals, and each of them start being fed higher and higher and higher amounts. With that, you then develop what's called an LD50, or you find at what level of feeding 50% of that population expire. Okay, so we're looking for the lethal dose at 50%. Now, not only do we look at lethal dose, we also look at the no observable effect limit. So how much can that animal eat and have zero impact on its physiology? And I'm talking about they weigh the liver, they examine the kidneys, they do all of these toxicity tests. So we want to find the two ends of this test. Number one, how much until they die? Number two, how much can they eat before there is no impact at all? All right, so now we know the two endpoints. Now, the NOEL is measured in milligrams of pesticide per kilogram of body weight. So we take that NOEL, and that is the no observable effect limit, and EPA immediately divides it by 100. Okay. So let's say that that experimental animal was able to eat 100 milligrams of that pesticide per kilogram of body weight and had no impact. All right. Well, after they divide it by 100, that is now your average daily intake. So now they say your maximum amount can be 1 milligram as a human, because they say we don't know how closely humans and experimental animals are. So we're going to put in 100x safety factor. So we're going to see at what level was that animal not impacted, divide that by 100, and now that is the maximum amount that a human can eat. So your average daily intake is the maximum concentration or tolerance that you should ever be able to contact, right? So we've got NOEL, we have your average daily intake, which is your maximum amount. Okay, so the next thing we need to know is how much pesticide can theoretically be applied and how often. So now we're looking at use sites. Where's it going to be applied and how often? Now, we also need to know how much of that pesticide remains on the food when it's marketed. So we're getting our residue data, our environmental fate data, and really starting to put that in the packet and use it for our tolerance information. Now, this has to include all routes of exposure. It's not just consumption of food, it's drinking water, it's residential exposure through, be it on your lawn, be it the flea and tick material that are put on your pets in your home. What is all of that has to be cumulatively added together to make sure you never exceed your average daily intake, because that's the maximum, right? We can never exceed that number. So all of it comes together. Now you say, well, how do you know how much somebody eats? Well, the EPA is constantly doing national surveys, and they break you out by gender, they break you out by age, and they say, okay, children in this part of the country are eating this many pounds of carrots per day, this many pounds of squash per day, this many pounds of apples per day. So they have those data, and they're very good, and they're always being updated because tastes change as time goes on. So now we know how much of each food people eat. We know the residues that are on those foods. And now we can start adding up and seeing how close are we to our average daily intake. Now, let's stop. Back about, I think it was 2006. No, it was before that, 1996. 1996, under the Clinton administration, he passed the Food Quality Protection Act. And basically, what that does, it says that any food that is fed to, quote, children or women of childbearing age falls under the Food Quality Protection Act. And what that did is it took your average daily intake. Remember, average daily intake is your no observable effect divided by 100. That's your average daily intake. Well, it takes average daily intake and divides it again by another factor of 10. So now there is 1,000x safety factor built in from the no observable effect limit. All right, so let's recap real quick. You start with no observable effect limit, divide by 100, you get your average daily intake. Then you divide it again by 10 if it's a food that falls under Food Quality Protection Act. So there is 1,000-fold safety factor in place for your exposure. All right, so how does this play out? Well, I would imagine you remember a few years ago, there was a lot of information in the news about glyphosate being found in orange juice and in cereal and beer and all of these other commonly consumed products. But people, they want to believe that there is zero in their food, but so many times there's not. But all these foods have tolerances. Okay, in the example of the orange juice, they said, okay, we found between 4 and 26 part per billion glyphosate in that orange juice. Your maximum daily allowance, or your ADI, for glyphosate is 1 milligram per kilogram of body weight per day. At 4 to 26 part per billion glyphosate concentration, a 22-pound child would have to consume 101 gallons of orange juice a day to meet that threshold. Okay, so all of these safety factors are in place. And yes, they found glyphosate in the orange juice, but EPA knew it was there. The FDA knew it, Food and Drug Administration, they knew it was there. It has all been taken into account. It has all been calculated to ensure that as a population, we stay below our average daily intake. Now, if that average daily intake number starts being exceeded, EPA will come back to the registrant and say, for example, okay, guys, you're having trouble with your ADI. It's time to start removing things off your label. Or you may have to remove citrus, you may have to remove carrots and other things to lower how much of that product is in the environment to ensure that we stay under the average daily intake. Now, you think we're finished, but we're not. Now you have to go back again and factor in threatened and endangered species. So let's say that there is an endangered species or a threatened species that is sensitive to a pesticide at levels below average daily intake and Food Quality Protection Act. If it is sensitive below that, well, then your tolerance has to come down. Because again, we can't be in a situation where we're causing an adverse effect on the environment. So you have to continue to drop that load in the environment. Humans and domestic animals are the primary driver of a lot of this registration process, but threatened and endangered species are very important, and they continue to be elevated in importance as each year goes along. So it is not just about people, it's also about these other species and ensuring we have a healthy environment. So what's the result of all of this work? All of this information now comes together and it helps write the pesticide label. And the label regulates where a pesticide can be applied, how often, at what rate. It dictates applicator safety, re-entry or end user exposure, and all of this information. So it all collectively starts coming in to inform the label. Now, after that label is written, it's not a one and done process. You don't have that label forever, because every 15 years, the EPA requires through FIFRA a full re-registration process where the companies have to go out, assemble all of these data again, pull in other experiments that have been done since the last review, and resubmit that packet. And quite often when they do that, we've learned more, and there's more environmental fate data, for example, that has been collected, and they go, okay, because of this additional data, we are now requiring these additional restrictions on this product. You may have to lower your use rate. You may not be able to apply as close to streams or open water. So they will start really changing based on the data. So every 15 years, you have to go through it, or if there is a significant concern. You may have gone through registration, a big important piece of data came to light 2 years later, boom, it can trigger a re-registration process. So we have to make sure the science is never settled with EPA, and they're constantly looking and ensuring that we're not having an unnecessary impact on the environment. Now, that's all federal. Now, well, let's look at states, because the states play a huge role in pesticide registration, use, and enforcement. So all pesticides, if it is going to be sold or distributed in a state, it has to be registered by the EPA and by that state. And there are a number of states that have that don't register all pesticides. So just because you can use it in Mississippi does not mean you can necessarily use it in Alabama, because you have to be registered in each state. Now, with this, states also have tremendous latitude to add additional restrictions onto the label. So this is a big deal, and it's quite common. So what do I mean by this? What are some of these restrictions and what do they look like? Well, let's just take Florida, for example. So if you are going to use 24D in the state of Florida, you have to then fall under the Florida organo-auxin rule, which requires a tremendous amount of record keeping and reporting that no other state requires. Secondly, you look here, it says there is a prohibition on allichlor. Allichlor is a soil applied herbicide used in production of food crops. And they just say, no, I don't care if it's registered by the EPA. It is illegal to use it in the state of Florida. And the EPA puts their hands up and says, Florida, that is your business, and that is absolutely allowed. There's also, you can even drill down in certain states and even restrict it even further. You can even do county level restrictions. Spike 80DF can be used anywhere in the state of New York except for Nassau and Suffolk counties. So you can restrict specific counties. You can even restrict times of year that a product can be applied. So this is for a dicamba material. It's a 2,4-D type material used in row crops. In Arkansas, they say you can't apply it after April 16th. Louisiana says after, or it can only be used, no, it can only be used between September and April. Minnesota's June 20th. You can add temperature cutoffs. So Minnesota and North Dakota say you can't apply if it's higher than 85 degrees Fahrenheit. Missouri says you can't apply before 7:30 a.m. or after 5:30 p.m. So again, you see that these states have tremendous authority to restrict a pesticide from absolute prohibition of its use in the state at all. It can prohibit certain counties. It can prevent different. It can require different use rates, different timings, all sorts of things. So again, this is very important for if people are concerned about a pesticide that is being used, help them understand that it has been fully vetted by the federal government and your state lead agency, which in the Florida is the Florida Department of Agriculture. They're the ones who ensure all of these things, all of these uses, and they ensure that the labels come in line not only with EPA but also with Florida policy. So these things have been looked at tremendously at both a federal and a state level. All right, so let's finish up here. Well, what have we talked about? Well, we've talked about the fact that FIFRA defines what a pesticide is. And if it is a pesticide, then it must be registered before it can be used. So again, you can't just go take a collection of molecules and go out and apply them in the environment. They must go through this massive registration process. The registration process collects the data regarding environmental safety, using all of those 243 different projects collected at a cost of $300 to $400 million over a time frame of 5 to 10 years. Uses all of that data to then form your label, and the label is a legally binding document. Okay, a label is not a use; it's not a guide or use instructions. It is legally binding, and the applicator must follow the label or they will face state and federal consequences. So if you are misusing a pesticide, you are, and by misusing, I'm saying you are using it in a manner not consistent with its label, then you are in breach of both state and federal statute. It's a big deal. Now, enforcement of the label is regulated by FIFRA, usually adjudicated to your state lead agency, again, in our case, Florida Department of Agriculture. They have the full right, ability, and capacity to come and investigate claims and to cite any individual that is misusing that pesticide. So it's not just that the label is formed and it's thrown out on the market and they just dust their hands off and say, all right, we trust you folks, go do the best you can. No, it is put on the market, and now there is a significant effort toward enforcing that label is followed and that everything is being done correctly. So, final take home message. The registration process is very, very long and it is exceedingly thorough. And it is not designed to be friendly to pesticides. All right. It's all about protecting the environment and the applicator. The EPA could care less if you're a pesticide, if you're a primary registrant and you're trying to get a label for a product. The EPA doesn't, they don't own stock in that company. They have no vested interest in the use of that material. So it is totally incumbent on the data to inform whether or not that product can be used in a way that is safe for the environment. So it is not about passing products through. It's not about anything else. It's about protecting people and the environment. So this is a long process, but I believe it is a process we can trust. Is it perfect? I'm sure there's a lot of people that have issues with it, but it is a process that we have, and it is very robust. And personally, I put my trust in the data, in the science, and in the individuals that are shepherding the process. So that is a very quick look at the registration process, what's involved. And with this, I would be happy to entertain a question.
I have a question about county restrictions. If you can
Okay.
hear me okay.
Yep, I got you.
So is when a county has a restriction, is that usually because they petitioned the state to have the pesticide not used in their county, or because they did a study, or is it going from the state saying the county won't, or is it the county asking the state not to for whatever reason?
It could be either. So, in that example that I showed, it's my understanding that Nassau and Suffolk County, New York, have very thin soils that with a lot of rock. So, that herbicide there is a soil active herbicide that is fairly persistent. And since the soil layers are so thin there and it's primarily rock, you'll have significant leaching, and that herbicide can end up in groundwater. So, because of the nature of the soil in Nassau and Suffolk County, they just say that product can't be used. Now, can a county petition uh, the state lead agency to have them exempted? They can. We have had counties in Florida attempt to do that, but our state agency has been quite resistant to follow along with those restrictions. So it can go both ways, and it depends on your state agency. But historically, the county level restrictions are because of some environmental quality factor.
Okay, thank you.
Anything else? Well,
All
if not,
right.
folks, thank you very much. Feel free if you have a question that comes in after the fact, feel free to email me or reach out to us. We'll be happy to help you in any way we can.
Awesome. Thank you so much, Dr. Farrell. So please join us next week on Wednesday, April 13th, as Jonas Grundman from Walla Walla District shares the history and evolution of the Corps' non-federal reimbursement program for aquatic invasive species prevention and response through watercraft inspection stations. In closing, are there any final comments from from the speaker? Or anyone else have a question before we take off and enjoy the great afternoon? All right. Well, thanks again for learning with us and have a great afternoon.